Hi again, last one I promise. So jumping right in, number 5 of the section of the unit review homework 5J. So here we have the fifth root of x to the third power equals 47. Using our rational exponents, the definition of rational exponents, I can change this radical, this fifth root, into x to the 3/5 power equals 47. Then to get rid of the exponent when it's a number, we raise it to the power of its reciprocal. So raising it to the 5/3 power. That cancels this one, leaving me with x equals 612.110. J, so here's K. I have 147 equals 12. I'm not going to fit this here. Moving on. 147 equals 12.1 times 1 plus x, the 2.3 power. So dividing out the 12.1, 147 divided by 12.1 gives 12.1488 equals 1 plus x to the 2.3 power. Getting rid of that exponent, raising it to the 1 over 2.3 power. The same thing with this side, 1 over the 2.3 power. This leaves 1 plus x over here, and 12.1488 to the 1 over 2.3 power is 2.9617. Subtracting 1 from both sides leaves x equal 1.962. Getting rid of that last decimal place because it asks to round to the thousandths. L, nice and easy. The function of the inverse of itself of x equals 20.2. Okay, which means that if the inverse of its own function is 20.2, then x must have been 20.2, because remember, functions undo themselves, so whatever you get out of it, you start with it when you have the inverse. Okay, and finally number 6. Whew, we made it. Find the equation of an exponential curve through the points 1, 5, and that's a 5, and 7, 32. So here we have exponential curves. So we have point ratio form, no slope finding, none. So we have here is x and y, and x1, y1. So plugging into point ratio form, remember we have this. Plugging everything in, y is 5 equals y1 is 32 times b, and x is 1, x1 is 7, so minus 7. So divide both sides by 32, and 5 over 32 is 0.15625 equals b to the negative 6th power, so 1 minus 7. So raise this to the negative 1/6. Same thing over here, negative 1/6. We find out that b equals 1.3626. So lots of us stop here and say, okay, I'm done, or you just plug everything back into the equation. Remember, to have an equation, you need to have a y and an x. So even though I did all this work, I'm getting no credit for this until I write the actual equation. So the equation has to start y equals. So I'm just going to plug in y1 and x1. So y equals 7 times, I did all that work to find b, we did it to plug it in, 1.3626 to the x minus x1 was 7, so x minus 7. So now this is an equation. We have y equals, something I can graph or make a table. We have an x in there, and I have the minus 7. Now you could use the other point if you want, so we could have y equals 5 times 1.3626 to the x minus 1 power if you wanted to use the 0.5 or the 0.15 instead of the 0.732. Ooh, and I messed that up. Sorry. Go back here. This should not be a 7. This is y. This should be a 32. My bad. Okay, so there you go. So 32 and then x minus 7. I'm glad I caught that. So you can use either x or y value as long as you use both of them in the same correct equation. But you have to get to this point or this point in order to get credit for an exponential equation. This is not an exponential equation. This is not an exponential equation. Finding b is not an exponential equation. You have to go back and plug them in. All right, study up. See you soon.